Welcome to another production from Pacific Paleontology. We're going to talk today about a few creatures, a giant sea snail, and an enigmatic sea star found high in the Santa Cruz Mountains. Well, here along Monterey Bay, storms are a constant part of the process that we are engaged with on a yearly basis. These storms can be fairly significant, eroding giant pieces of our coastal cliffs here. Um, Sometimes the storms are so gigantic they put tens of feet worth of driftwood up on the beach, as was such the case recently um, during one of the last El Ninos. And during those times, many rock falls happen along the cliffs here. And those rock falls reveal the fossils that we study here at Pacific Paleontology. So one day we started out on one of our typical expeditions here one morning and didn't know what we'd see. Back in the old days, we'd be able to walk on this beach and not see another person, but now in the 21st century, we see hundreds, uh, if not more, people walking along the cliffs. And here you can see one of the giant rock falls. Um, these rock falls have been happening, of course, for time immemorial, um, and we know that people have been experiencing them, of course, since the 1800s when um, this area of Monterey Bay first started being studied for its fossils, um, and those processes are still going on today in the exact same spots. Well, one of the greatest pleasures is studying in this area of this eroding coastal cliff region because you really don't know what you're going to find when you embark on one of your expeditions. Um, these rock falls tend to concentrate in El Nino years, and there's a whole suite of patterns and processes that are associated with these rock falls that we've been studying for the last actually 45 years, and so that's one of the things that we're very concerned about and interested in here is how and why these rock falls happen. Well, on this particular day, we were headed out. We made sure we had all of our usual gear that we take out when we go fossil collecting, which includes our Chalky Lab Chaco, who is a great helper and a perfect lab for the lab, so to speak, the outdoor lab. Well, these rock layers split apart and open up just like the pages of a book being flipped back, and they reveal a story that's told about the evolution of Monterey Bay. And even today, 150 years, over 150 years from the time that this area first started being studied for its fossils, we are still being told new stories every time about the evolution of life here in Monterey Bay. Well, on this particular day, I happened to find this particular fossil. You can't see it close right now, but I'll show you a few more close-ups. This is the block it was found in and the layer. These are some of the tools that we use to extract these fossils and study them. And here you can see that same background. Well, a little bit closer, we're able to see what this is, and this is just the part of a gigantic sea snail that is partly covered in sediment and rock here, and this is what we happen to be after today on this particular day, back a couple years ago, and this is it just being exposed here. Here it is out in the block that it was taken out in. We don't actually extract the fossils without one of these blocks because they're so fragile. We take it and block it out in the rock and sediment that entombed it for the last 5 million years, and take it out so that in that block so that we can do the detailed prep back in the lab. We also record all the associated data um, that comes with the fossil. In the particular layer it is, which layer it is, what's the conformation of that layer, um, what's the distribution and disaggregation of the bivalves. We see here that the layer it was found in is including a bunch of disaggregated bivalves, and the layer below it has a lot of articulated bivalves, and that's all really important information that we record. We also record any the species, the associated species. Here we have a giant um, um, crepidula, Grandicrepidula princeps, the giant princess slipper snail with a calyptriid that is a hitchhiker, an ancient ecological interaction. That's also very important to record. So all that information gets recorded along with the specimen so that we can have all the proper data we need to interpret it. Back at the lab, we get ready to prepare it. We have a suite of tools that we use. These are among some of those tools that we use to prepare these fossils. I tend to prefer preparing these fossils outside in the sun on a warm day. And so I have my handy stratigraphic column right here to help me interpret the layers. But on this particular day, we migrated inside. Well, here's that snail that we extracted, a little bit more exposed and prepped up so that we can see what it looked like. Again, this is a giant sea snail. And let me move to a 3D representation of this fellow so you can see exactly what he looked like. Here he is, or she, here it is, in a little bit more detail. You can see that it's in the block, and we keep it in the block. This particular species has a paper thin shell, and you can see that paper thin shell right there. And if we had taken this out of the block, it would be very easily disintegrated. And the reason why we find so few of these is because of that paper thin shell. It's just very, very fragile. So there it is. There it is in a little bit more. Another view. So I've actually been finding this particular snail since the 1980s, over 40 years ago. And, we used to call it something a little different back in the old days. But repeating patterns in biology often indicate, associated specimens, related taxonomic affinities. And just like with anything biological, repeating patterns indicates close evolutionary relationships. So here's a few of the specimens that we've found over the years. There aren't a whole lot, as I mentioned, hardly any, in fact. And so that's why this particular creature is so important. Step that we do is literature research, and to try to figure out, once this specimen has been collected as much as possible and prepared, we try to do literature research to see what exactly it is. And literature research encompasses going to museums, and here we are, Chuck Pal and I, at the Academy of Sciences in San Francisco, comparing specimens in their collections with our specimen that we would like to identify. This particular creature we figured out was in the genus Clinopegma, and Clinopegma was first named for this particular one by Ulysses S. Grant IV and Hoyt Rodney Gale in 1931, and attributed to this particular specimen. And yes, Ulysses S. Grant is in fact the great-grandson of our own President of the United States, who I happen to share a birthday with. And in their famous monograph, Pliocene and Pleistocene mollusca of California, um, the um, the genus Clinopegma, in Latin, clino is slope and pegma is point or stick. Not sure how that relates to this new genus or this specimen, but that is the Latin derivation of it. Um, uh, Clinopegma stantoni, the particular one that we have here in the Piersma, was first named by famed paleontologist Ralph Arnold. And Mr. Arnold um, designated this species from outcrops of the Piersma Formation up near Ano Nuevo, just south of Ano Nuevo, as well as the Piersma Formation here in Monterey Bay. And uh, this this particular species is isolated to those two locations only. It's only known from that narrow stratigraphic and geographic range, and so it's quite limited. And Ralph Arnold named Clinopegma stantoni, of course, under a different genus, but um, he named it in 1908. Now, also in 1908, he described an isolated deep sea brittle star that was found high up in the Santa Cruz Mountains. And this brittle star, he named it after um, Santa Cruz. He named it Amphiura sanctae crucensis. And recently, this past summer, we discovered a treasure trove of these brittle stars that hadn't been seen since in over 120 years since Ralph Arnold first described them. Only here in Santa Cruz, and a treasure trove of dozens of these brittle stars high up in the Santa Cruz Mountains amongst the redwoods, and actually literally amongst the roots of redwoods. And these are between 8 and 9 million years old. So very interesting coincidence that he happened to publish that brittle star paper same year that he published Clinopegma stantoni. And there's a picture of the original specimen. This one happens to be at the U.S. National Museum, but that's the one that was found high up in the Santa Cruz Mountains right there. Well, that's it for now. Signing out from Pacific Paleontology with another episode of Deep Time Santa Cruz County. All right, more next time. Over and out.